Good morning, sir.
I think there was some issue. I don't know why you are not. There may be network issue also. Okay, please tell me if you have any problem. Now audible?
Yes, sir.
Any network issue, please tell me. I will connect. So today we are going to start this design of shallow foundations. So in the previous chapter, how to calculate the bearing capacities, settlement, allowable settlement, and so on. Okay. Now, how generally we design a foundation. So before going to the design of foundation, let us focus what are different types of foundation we have again. Okay. Types of shallow foundations are when we call it as a shallow foundation when the to the depth. Okay. So this is Terjagi given this one with this greater than or equal to the depth. So if you recall, we have the strip footing. Here the strip footing is along the wall. Okay. And our spread footing is isolated as the name suggests. Okay. And this is the elevation. If it isolated footing looks like this, and this strip footing along the wall. Okay. Along the wall. So it looks like. So this is strip footing, isolated footing. And sometimes what we do is so suppose the footings are very near and are there may be okay where we cannot extend our isolated footing. In that case, what we like to combine both the footings. That is called the combined footing. Okay, so when the property line is so close to one column that is spread loaded when kept entirely within the property line. Okay, so by combining it, the load is evenly distributed. That means to avoid eccentricity, if you have problem with the property, what generally we do is we'll combine it. This combination also sometimes we do trapezoidum also. Now maybe this side will make a trapezoidum. Okay, also we can do it. Again, it depends on the design which is carrying. Okay, suppose exterior column is carrying more load than footing. Strap or cantilever footing. As the name suggests, suppose the footing and if you have some differential settlement or which is meaning both footing, what we do is we provide a strap or like a beam to connect both the so which is more economical for us. Okay, so designed that their combined line of action through the resultant of a total load. That means economical than the combined footing when the allowable pressure is relatively high. When they are large, what we do is we combine with that. Next is the raft foundation or a mat foundation is that. It is a large slab supporting the number of columns. That means we will then what we'll do is we'll provide a mat entire, okay, under the entire structure. Okay, or entire structure. So nowadays we see some of our high-rise buildings cities are mostly designed and resting on the raft foundation only because and the settlements also we can go much. We have seen the allowable settlement also more for the and there won't be differential settlement. So what generally we do is we go much deeper. That's why if you see or if you go and visit in wherever your cities, right, which cities, whether it's Chennai, Bangalore, Hyderabad, or Pune, or some other places, Noida, Gurgaon, NCR region. So what you see is they are going much deeper, and what they are doing, they are starting and below the ground level, no, they are providing. That's why our shopping complexes nowadays are multiplex. This whatever you see provide the parking underground. Okay, so likewise we are seeing that nowadays structure. Now, what is the depth of the foundation is? Depth of the foundation is very important. As we have seen, but we have to have some minimum depth, right? Rankines also given the minimum depth, how much we should go for. Okay. Foundation on the soil, so there should be some minimum depth and so on. Then only what happens, no, so on. So must be laid suitable depth. We have to see the suitable 1 or 2 meter. Again, it depends charge load and other things while designing. We'll find out all. So this is how the mat foundation. And this is the plan. These are the columns. We will take out the column from the mat Raft foundations. Okay. Sensitive foundation actually. So here, whatever soil we are taking out, it is filled with the concrete. So effective stress or increasing the stress is zero, null. There won't be much. That's a good sign for our soil, right? So more stress increases means bearing it will be difficult for this. So below the frost depth, we just keep this footing should be carried below the depth of the and the zone of the soil volume changes wherever soil changes the volume. Okay, we will go much deeper than that and adjacent to take care and sloping ground we have to take care like if this is a slope road. So many north Himalayan region, no, so there providing footing is very difficult, no, right? So both are at the same. We are giving you proper depth. Okay, so we are maintaining the proper depth. Otherwise, what happens? This will topple. Okay, so generally one is to be here maybe mention the angle maybe 30 degrees. Moreover, the minimum distance of the footing to be sloping ground should be 19 centimeter, and we should see that water table also above the groundwater table as far as possible. Okay, the presence of the water again will create contact with the footing or a soil, which is undesirable to us. Okay, but suppose you are going for a bridges and other things, right? So that we have to take care should be placed the below. That means because of the waves and other things, scoring will happen. Okay, so underground defects, if at all located by the penetration of the underground defects, such as faults, caves, mines. Okay, so where important are man-made in anything, sewer lines, water lines, pipelines. We have to see everything. Okay, their roots holes. Okay, if the root holes or cavities caused by the burrowing or worms, the footing should be placed below that. So Rankin, this guy has given already. We have a minimum depth, and IS code also adapted that one. So if you know the at least 15 centimeter below the natural ground, that means half a meter. Okay. However, in the case of rocks, only top should be removed, and this is the minimum. This formula is very important formula. They will ask in the gate exam. Minimum depth I have told you last time only. What are the foundation loading is all about? We have dead load, live loads, wind loads, no same thing. Whatever you have for so there will be dead loads. What are the dead loads? Okay, dead load permanent feet. Okay, floor, walls, columns, beams, and other things. What is coming to the loads? Live load means moving loads permanently, which is not much permanent. Okay, load due to the main machinery, etc. Wind load, you know that for high rise building. Snow load, if at all, no, in be accumulated. Then earth pressure, if you are considering embankment or earth pressure, already we have seen that particular in the chapter 19. Then water pressure also you have to consider if it is when you design it, and occasionally earthquake also if it is in the zone, which zone it is important. 1, 3 and so on, we have to consider that. Laterally force also. Now, computation of design load, how generally we do computation of this one. So whatever you study for your RCC, earthquake and all, dead load plus live load, if it is having wind dead load plus live load plus wind or seismic load, because this will happen occasionally. Okay, it's given this already we have seen that. Okay, if the wind load is less than 25% of that one, live load it may be neglected. This one. Now, what are the principles of the design? Okay, so this we will read one by one. Is design using the following procedures. So we'll follow some procedure. The investigation of the first, what we'll do is here if you see before actual design, it is essential to estimate the dead load, live load, and other things, and the frequency that okay, and so on. After the bearing capacity of soil depends upon the depth of the foundation, length, width, and limited. So here the investigate first what we'll do, we'll do all our investigation and you know plane values or plate load test and so on. We'll do it. Then what we'll do is the footing is designed using the following procedure. The safe bearing capacity determined using the method discussed in the previous chapter. Okay, for a small taken in presumptive values. That means we have seen that table if you recall. So suppose it is a gravel, sand, assume we can easily assume it. Okay, this is well-known process. Then footing is proportional to bearing capacity determined. Okay, in step 1. Then the maximum settlement of the footing is determined using the method and we know that okay, differential settlement between the footing is made. Angular distortion is parts of the structure. The maximum settlement, the differential settlement, angular distortion obtained in that one. Step 3, the allowable one. Okay, again the table it is given. If the values are not within the allowable limit, the safe bearing capacity is revised. Is repeated. The stability of the footing is checked against the sliding overturning also. The factor of safety should not be less than 1.5 when the dead load, live load, and the earth pressure and wind load pressure However, if the only dead load and live load and the earth pressure are considered, it should not be less than 1.75. The corresponding overturning is 1.5 and 2 respectively. So what we'll do is we will do this proportioning. Okay. Here design ups will start with the strip footing. Okay, in the next class. So we'll read this one. To reduce the differential settlement, variation for footings on fine grained soils. It is all the footing in such a way that they have equal pressure under the service load. All the footings would be settled by equal amount and the differential settlement would be considered reduced. The following process. So what we'll do is we'll see that it will settle properly. So the dead load from the east footing is determined. So these are the steps. Okay, the maximum live load to which each footing is subjected. The ratio of the maximum live load to the dead load for each footing is determined. The footings that to the dead load ratio is taken as the governing footing, and this area determined by the relations dead load plus live load divided by allowable bearing capacity. Then things are determined. The design bearing capacity of all the footing except the governing. Okay, so service load for governing footing. Then the area of other footing is determined. We will follow this procedure as spec suggested. Okay, before going for the design. And this is given as A. So what you do is still read up to this today. Okay, when you come, what are those types of footing is all about. Okay, what is spread footing, what is combined, what is raft footing, and you read the previous chapter also, whatever you have seen the previous chapter once. So in the previous chapter we have seen allowable settlement, allowable bearing capacity, and so on, minimum depth of the foundation. So just read once, then you will understand.